So now our next question, exercise question is about the upper bound of a sum of these measurements. Na? So we have a question, exercise 10.2. It's about question number 1. Find the upper bound of the sum of measurements find the upper bound of sum of each of the uh, each of these pairs of measurements. Number 1, the part A is 299 29 point 29.7 seconds and 31.4 seconds. Now it says both to 3 significant figure. This is the good. Both to the 3 significant figure. So what, when it says the both to the 3 significant figure, it is our now the part is about it's about the accuracy now. Now here you note this is the first significant number 2, and this is our significant number, and this is our third significant. Similarly here is also same. So the 7 and a 4 are on the 10th place number now. So it's on the 0.1 place or 10th place. This is our these number on the third significant number now. That's why I'm choosing 0.1 as a accuracy. Why we have chosen this? No? This is like a we had rounded this 29.7 on the third significant figure. No? That's why it's like this. No? So, or you can comment me. Now the error for this will become 0.1 divided by 2, and you will get 0.05. So now let's do the solution. But the question, what the question says is upper bound of a sum. So the upper bound for this and upper bound for this number. No? So upper bound for this 29.7 is upper bound of a smaller is 29.75. And lower bound the upper bound for larger number is 31.45, because we are adding the error term. Now I'm writing it's in a rush way. So upper bound of sums is the sum both, no? 29.75 plus 31.45. So 31.45, 29.75, add these, no? So 5 plus 5 you will get 0, 1 will go up above. So 1 plus 5 you will get 5. 1 plus 4 you will get 5, 5 plus 7 you will get 2 point, and 1 will go up. So 9 plus 1 it's 10, 10 plus 1 it's 11, 1 will go up, you will get how much? It's get 6. So the sum of these is 61.20, 61.20 seconds, 61.20. Now we have exercise 10.2, but the question is very different. So exercise 10.2, we have question number 1. Find the upper bound of the sum of each of these pairs of measurement. Now we have a part B. This is our part B. B is 11.04 seconds and 13.46 seconds. Both to the nearest hundredth of a second. Both to the nearest hundredth of a second. Or it's saying like a three significant figure, I think so. But let me see. No, it's correct. Let's do it. What it says. So we are finding the upper bound of a sum. So for the upper bound of a sum, first let's write the formula for this. Solution is this: upper bound of a sum is upper bound of smaller plus upper bound of a larger number. So smaller number, larger number. So for finding the upper bound, let's see what is the accuracy. No? So now the accuracy is 0.01. So for finding the error term is divide accuracy with 2. So accuracy divided by 2, you will get 0.005. So this is our error term. Now you will add this error term to this. So 11.04 plus 0.005. plus 13.46 less 0.005. So you will get 11.045 plus 13.465. Now add these terms. No? So 13.465, 11.045. So 5 plus 5 you will get 0, 1 will go up. So 6 plus 4 you will get 10, 10 plus 1 it's 11, 1 will go up. So 1 plus 4 you will get 5, decimal, decimal you will get the decimal, 3 plus 1 is 4, 1 plus 1 is 2. So you will get 24.510. So this is the upper bound of a sum. So now we have a part C from this question. Exercise 10.2, part C. For this is we have 6.42 centimeter. Oh, sorry, it's meter. And 5.97 meter. So both to the nearest centimeter. So the accuracy is both to the nearest centimeter. So the number are in the meters. No? First, we will convert these numbers into. So the solution is the same. So we have to find the upper bound of a sum. So this is also from a question number 1, same question. So find upper bound of sums. So finding the upper bound of the sums. So we will find the upper bound of this smaller number, upper bound of a smaller number, and the upper bound of a larger number. So the situation is easy. So, but first we have to convert into the meters into centimeters. So 1 meter is equals to 100 centimeters. So 6.42 will become 642 centimeters, and 5.97 into 100 you will get 597 centimeters. So this is our step number 1, some kind of convert the units. No? Now the nearest, both to the nearest centimeter. No? So the accuracy here is, so the accuracy is 1 centimeter, and the error is 1 centimeter divided by 2, it's become a 0.5 centimeter. So this is our error. So for finding the upper bound of sums is upper bound of sums is upper bound of this 6.42 plus 0.5 plus 597 plus 0.5 upper bound of this. So now we are finding the upper bounds because we are adding the error to the original term. So this is our original term, this is our original term, now this is error term. So now this become a 642.5. Next, this will become a 597.5. And last, while adding these both, what we will get is let's do it. Not seeing from, or I might use the calculator, but let's not use the calculator. 5 plus 5, 0. 1 will go up. So 1 carry. So 1 plus 2. 1 plus 2 is 3. 3 plus 7, you will get 10. 10 go. 1 will go up. So 1 plus 1 carry, and 1 plus 4 is 5. 5 plus 9, you will get 14. 1 carry. So 1 plus 5, it's 6. 6 plus 6, it's 12. So you will get 140. 140. Is it right or is it wrong? You can check and you can tell. Let's do from the calculator. Is it right or is it wrong? Then it's right. That's okay. If it's not right, we'll correct it. 0.5 plus 597.5. So this is correct. So this is correct. 1,240 centimeters. Let me convert this into a meters. So 1,240 centimeters divided by 100, you will get how much? You will get 12.40 meters. Now this is our upper bound of sums. So now we have a question number 2 from exercise 10.2. So it's exercise 10.2, question number 2. What it says, find the lower bound of the sum of measurements in question number 1. So in a question number 1, there was to find the lower upper bounds of sum. So now we have a lower bound of a sum. So for finding the lower bound of a sum, so in a part C, there was a question which says that we have a 6.42 meter and 5.97 meter. The two measurements are given. The first one is 6.42 meters and the second one is 5.97 meters. So both to the nearest nearest centimeter. So now here the question is about to find the lower bounds of the sum. No? So for finding the lower bound of a sum, so lower bound of sum of the sum of the measurements. I might call this the lower bound of a sum. Just now. So measurements. So lower bound of this one, the smaller one, lower bound of a smaller number, the lower bound of a lower bound of a large number. So first convert these, because we have already converted this into a centimeters. So 642 centimeters this become, and this will become 597 centimeters. So now the accuracy will become a 1 centimeter, and the error term here will become a 0.5. This is our error term. So 642 meters centimeters minus 0.5 plus 597. I might write the smaller number first, and 597, 597, 97 minus 0.5. This is our error term, plus 642 minus 0.5. This is our error term minus from the larger. It is our smaller. So this will become a 596.5 plus 641.5. So while when we add these terms, we will get the lower bound of the sum, 641.5, 0.5, and 6, then 9, then 5. So 5 plus 5, 10, 0. Here will become a 0, and 1 will carry. So 6 plus 1 you will get 7, 7 plus 1 you will get 8. 4 plus 9, how much you will get? It will make 13, 13, 3 will remain here, and 1 carry. 6 plus 1, 1 plus 5, it's 6, 6, 6 plus 6 is 12. So in last we will get just 1238 centimeter. So while when we divide 1238 centimeter with 100, though you will get 12.38 meters. So this is our result, final result. So this is our lower bound, of this one, of measurements. Now we have say exercise 10.2, same exercise, but question is different.